I started this engineering analysis thinking that Project Highland was just Model 3 with Gigacastings and structural pack. But going down the manufacturing rabbit hole, I was awestruck again and again. The engineering I saw was magic, or even witchcraft. But it's not just the alien technology that blew my mind, but also the sheer scale of it and the implications. Project Highland and the new Tesla Pi and Tau should do to the internal combustion engine what Model T did to the horse and carriage. There's no turning back, and the dies have been cast, so put on your sunglasses, because the Ice Age will soon be over. Hey guys, welcome to Connecting the Dots, the channel where we try to predict where disruptions will take us. I recently did a video that went viral on Tesla's Project Highland and the upcoming Highland Model 3 and Tau. The video explains why I expect Project Highland to be far more than just a refreshed Model 3 with 2 Gigacastings and a structural pack. If you haven't watched it, there's a link in the card above. That video described the why, but it's the engineering analysis that describes the how. It's too easy to hype that Tesla will slash 99% of their costs and shoot cars out faster than the speed of light, but without the engineering to back it up, it's only tall tales and hype. I'm considered a world-class engineer. I studied aerospace and majored in structures and manufacturing. I worked in aerodynamics, simulations, software, and systems engineering. I did lots of development and tons of research, and I've worked on small systems and huge world-renowned ones. I don't pretend to know which roads Tesla will take on their way to extreme scale, but after analyzing Highland, I do see a map leading there. The third-gen EV platform opens numerous roads to slashing production costs and time. And if I see this many roads, then Tesla sees countless more. The map has too many roads and the time is short, so I'll split the scope into 2 videos. This one will provide my baseline assumptions and focus on Gigacastings, and an additional video will provide all the rest, such as seats, wiring, drive factory, and Optimus. To get notified, please subscribe to my channel and hit the bell icon. These videos, like my previous one, originated from an idea sent to me by my patron Scott M. If you like my videos, please consider supporting me on Patreon with the link below. It's patrons that make this channel possible. So by joining, you'll get my sincere gratitude, along with ad-free early access to my videos and additional Patreon-only content. You can also support me by hitting the thanks button or just like and subscribe. This really helps the channel. Now buckle up and get ready, because this is the final disruption of ICE, and disruptions are never boring. What's in a name? Before we start, here's a quick update on the previous video. In that video, I referred to the Highland cars as the new Model 3 and the smaller Model Tau. Since then, however, some interesting points began to appear. First, K10 dug out that on February 22nd, 2022, that's 2/22/22, Elon tweeted a rather cryptic, Tau is larger than pi. This is mathematically correct, as the circle constant Tau is equal to 2 times pi. Also, Elon's birthday is on Tau Day, which is June 28th. But with no apparent reason to tweet this, I, along with many others, see it as some confirmation that the 3 could be called pi, and the 2 could be called Tau. After all, the smaller Tau is much more significant than the larger pi, just like Model 3 is more significant than Model S. Then, someone recalled that Elon once said that Tesla will stop using the model prefix on future cars, which makes the cars the Tesla Pi and Tau. No model before that. And to add fun to our party, Elon then tweeted the letter Omega. And since Omega is the final letter of the Greek alphabet, I see future names as follows. The new Model 3 will be the Tesla Pi, Model 2 will be the Tesla Tau, and the Robotaxi, the car to end all cars, will be the Tesla Omega. These are just guesses, but guessing is fun, so I'll use these in my videos until the real names are revealed. Others suggested the Tesla Q and other names, so join in on the fun, and let me know below what your guesses are. Assumptions and goals. Assuming that Project Highland is Tesla's Model T moment, its prototype for optimizing the platform and the way EVs are produced, I expect the project's goals to be costs, time, and product. Tesla's mission is to transition the world to sustainable energy, and its goal is to sell 20 million cars per year by the end of the decade. To do this, they need to make truly inexpensive cars, which almost everyone can afford. Think Corolla, Yaris, and small Suzukis. If Tesla plans to make these while retaining margins, they truly need to slash production costs. And just like with Ford's Model T, if Tesla slashes costs and prices, it should have massive demand. If Tesla plans to meet it, they need to slash production time and start spitting cars out faster than ever before. And where costs and time are not significantly affected, Tesla will always strive to improve its products. Costs, time, and product have many interplays. For example, if Tesla spends less time producing each car, this not only lowers production costs, but also enables producing more cars from the same capex, and increases economies of scale, which reduces costs even more. And reducing the car's weight not only improves its driving dynamics, but also increases its economy, which means less batteries are needed. And less batteries mean lower costs and even lower weight, which forms a virtuous cycle. Holy Teracastings!
He can pull a rabbit out of the hat whenever he wants. And this is another rabbit and another hat.
1. The bottom line. Most Tesla fans agree that the Project Highland platform will use Gigacastings, but the billion-dollar question is to what extent? Like everything else in this video, my answer is that I don't know, but I will share my thoughts and reasoning. There are 3 basic options for using Gigacastings. 1. Casting only the lower chassis, producing the new cars the same way as Berlin and Austin Model Ys. 2. Also casting the top hat, which is the upper part of the chassis, and then connecting it to the lower chassis. And option 3. Casting the entire chassis as a single piece. I won't keep you waiting, so here's the bottom line. I believe that Tesla will cast the entire chassis in separate parts, as described in option 2. It is possible that in the future they'll try option 3 and cast the smaller Tesla Taos chassis as a single piece. At this stage, however, and especially for the larger Tesla Pi, they'll probably cast the upper part separately and then marry it to the bottom. To differentiate the single cast chassis from current Gigacastings, I'll refer to it as Teracasting. This also conforms to Tesla's naming methodology when one Gigacasting replaced 2 half-sized Megacastings. For those wondering what this single-piece nonsense is about, in 2018, Tesla filed a patent for multi-directional unibody casting machine for a vehicle frame and associated methods, which describes a new casting machine that Tesla plans to use for casting entire bodies in a single piece. When news of this patent broke out, Elon replied to whole Mars catalog saying, "With our giant casting machines, we are literally trying to make full-size cars in the same way that toy cars are made." 2. Why Gigacastings won't do. I believe that Tesla will cast the upper part of the chassis, and in the following sections, I'll give you the reasons behind my belief. I'll start with the abstract and end with specific, but before giving my reasons, let's first show some of the reasons on why castings are ill-suited for this job. There are several takes on this, and the best one is from my friend Tavi Cocochip. Tavi is a materials expert, and here's what he wrote. "I really don't get why people with zero expertise in auto body design or in metallurgy feel they can figure out what a whole industry can't. You think that combination of metals is accidental? As in, Tesla randomly decided to mix different steel grades in the chassis? No. Each one of those members is made using a specific steel grade because it's necessary. And no, cast aluminum alloys can't replace forged ultra-high-strength steel members, as their yield strength is much lower. It would require members with much thicker cross-sections to get the same performance. And no, for the nth time, castings are very poorly suited as outer panels. High-pressure die-cast castings are ideal for replacing structural components with complex geometries, not for two-dimensional components best made by stamping sheet metal. Castings are not a universal replacement. Does it make sense from a cost perspective to replace fairly long and straight structural sections with high-pressure die-cast castings, even assuming the mechanical behavior is similar enough? Other than castings are cool, I'm not sure there are benefits to replacing stampings there. Let's tackle these one by one. Wondering why Tesla fans think we can figure out what a whole industry can't is a moot argument, as the same could be said about lower body Gigacastings, which until Tesla arrived, the industry resisted doing, and us fans discussed long before the industry reacted. And saying that we shouldn't think Gigacasting the upper body is an option because so far Tesla intentionally chose different kinds of steel is also wrong. By this logic, Tesla would never use Gigacastings, and Model Y would still be using the hodgepodge of stampings that made early Model 3's wheel arches. Each of these stampings was highly optimized for its own region and use, without noticing that the overall solution had become a mess. All other points Tavi raised are admittedly valid, so I won't even argue with them. I agree with Tavi that it should take a huge engineering effort to make a cast upper body viable. And I agree that using cast aluminum for the thin pillars will possibly be heavier and thicker than doing the same pillars with layers of various steels. The list goes on, and I won't argue with these. Instead, I'll reply, so what? And having said this, I will tackle them in a hierarchical manner, going from the philosophical to the practical. 3. Desire moves mountains. Tavi is highly intelligent and knows his stuff. I also see him as a friend, so let me address him personally for a moment. Tavi, my friend, I love you, and have nothing but respect for you. But in this case, your being an expert is holding you back, just like those NASA experts explaining why reusable rockets can't be done, or like Bob Lutz explaining why Tesla will fail in EVs. Your knowing how and why things are done creates a blind spot which hopefully I can shine a light on. This isn't a hit against Tavi. He really is a smart guy, and I really recommend following him, like I do. And I do agree that cast aluminum alloys are far from optimal for a side structure, but engineering is the art of making compromises, and sometimes it's better to pay a price on one thing if this lets you gain much more elsewhere. So before ruling castings out because they're not as good, we must also check the follow-up questions. Can we overcome the problems? At what cost? And what do we stand to gain? There are many examples of doing dumb things locally for a greater overall gain. For example, reusable rockets cost much more to make and can carry much smaller payloads than equivalent rockets which aren't reused. Rocket experts preached not to take a single pound of fuel over what is needed to get into orbit, as payload is very limited anyway, and that pound could have been precious payload. But the willingness to pay these huge prices of lower payload, higher unit cost, and huge development effort significantly reduced SpaceX's overall mission cost and were a huge step towards its mission of making humanity interplanetary. SpaceX paid the price, and the rest is history. Here's another example of this.
For the sort of wheelhouse areas of the body, there was a lot of engineering done, and there were a lot of right answers to the wrong question. So somebody would say, like, well, what's the best material to make this little section of the body out of? And what's the right material to make this little section? And I think we've got probably the best material science team in the world at Tesla, and actually a lot of them also do work at SpaceX as well. The engineers would ask, what's the best material for this purpose, best material for that? And they got like 50 different answers. And they were all true individually, but they were not true collectively.
So sure, getting a cast side structure to work will take a huge engineering effort. And sure, there's a chance that even after that, it will be slightly heavier, thicker, and with higher materials costs than with using stampings. But looking at the overall picture, it could still be a win, because here's what Tesla could gain. A much smaller factory footprint and volume, much faster production, much fewer robots and robot downtime, much lower human labor, much fewer parts and sub-assemblies to keep in inventory for years upon years, much fewer suppliers to manage, to get required connectors, bolts, adhesives, etc., just in time to the factory, and tighter product tolerances with more consistency. Slashing production time is at the very core of Project Highland, so I am certain that if only it's possible, then Tesla would want it, but that's just the tip of the iceberg. The true way to see it is through Elon's eyes, and for him, Project Highland is a stepping stone on the way towards an alien dreadnought factory that could spit cars out with no human intervention. Reducing hundreds of processes and parts into one is a huge step towards this vision, so Elon and Tesla will desire it. And like Henry Ford in the Cast V8, or Elon in the early SpaceX and Tesla, desire moves mountains. 4. Ask Moore and Wright. The previous reason was philosophical, and so is this one. In 1998, Max Schultz predicted in this article the imminent end of Moore's Law. And 5 years later, this paper by C. Mack predicted the same. But go forward 17 years to 2020, and Moore's Law was still alive and kicking, as it is today. For over 50 years, experts much smarter than me repeatedly predicted the end of Moore's Law. Again and again, they had valid reasons, yet again and again, unexpected breakthroughs emerged, and the law soldiered on. In 1958, the integrated circuit was invented. In 1963, the CMOS process. In 1967, DRAM. And in 1980, chemically amplified photoresist and laser photolithography arrived. The list goes on and on, but the great thing about Moore's Law and its Wright's Law sibling is that they don't care which problems will arrive and what breakthroughs will solve them. They just assume progress, and technology never fails. Sometimes it lags a bit behind, and sometimes it leapfrogs ahead, but progress always happens. And compared to the breakthroughs which I just mentioned, Tesla's problem is truly child's play. The big problems of Gigacastings are already solved, and I don't see any showstopper which cannot be solved via good engineering. Again, where's a will, there's a way. And with an incentive as big as accelerating the world's transition to EVs, I do count on Tesla's engineers to find it. 5. But is it possible? The basic answer is yes. Using castings does not break any laws of physics, so yes, it's possible. Let's go on. 6. But is it smart? Let's put philosophy aside. It's all very nice to say that it's possible to teracast the entire chassis, or to cast the top part and marry it to the bottom, but if the result is a heavy build that will look like a Soviet car from the 90s, that wouldn't be very smart, would it? Without doing the actual engineering, it's unclear how heavy and pricey the casting would be, but I do have a guess. From just playing with this problem in my head, I came out with a few ideas on how the main problems can be overcome. And if I came up with these, you can count on Tesla having countless better ways. The bottom line is that I am certain that it can be done without making the chassis bulkier or more expensive. I might put my ideas in a separate video, but if you want something to munch on for now, consider that in many ways, alloys are like composite materials, with pure aluminum as the resin. We'll get back to this later in the video. 7. Seeing is believing. Now forget all I said, because there are much better reasons for my conviction that Tesla will cast the upper body or possibly Teracast the entire chassis. The first reason is that seeing is believing, because a few weeks ago a photo of the structure leaked. Of course the picture shows a Cybertruck's chassis and not the Pi or Tau, but that's even better. Problems grow with size, and if Tesla's confident enough to test cast structures for this huge oversized truck, then smaller models should be easier. Some viewers might point out that Cybertruck has more room and weight to spare, but not so. Fighting for range is still a problem, so Cybertruck can't afford to add weight. In addition, loads on a truck vary much more than on cars, which makes the structure even beefier. The exoskeleton might help, but despite that, if Tesla is now testing castings for the mighty Cybertruck, chances are that its baby siblings also received that treatment. 8. The invitation. And here's another major dot to connect. By now, you probably know that Tesla's Investors Day invitation shows the side profile of a car. I've heard suggestions that these are just stampings, but a closer look at the picture reveals that it has depth. These are not several stampings lined on a rack, and not even a single one. Just look at where the dashboard would be, and it's clear to see a line going in. So it's a chassis, not a 2D stamping. But that doesn't say much because it could be constructed from stampings like all current Teslas. However, in previous Tesla events, the invitations highlighted major breakthroughs like the Dojo chip, tabless battery, and Tesla Bot. And if this chassis is like all others, why put it as the Easter egg? You could say it's from a new model, but there are many other ways to show new models, and since Tesla showed the chassis side profile, to me it seems clear it's because it's a breakthrough, and this breakthrough is that it's cast. And one more thing. Remember how my friend Tabby pointed out that castings are ill-suited for use as visible outer body panels? I fully agree, and therefore I expect the new chassis to be fully hidden, with stamped sheet metal attached to it everywhere, same as is currently done for front fenders. The invitation's granularity makes checking this difficult, but I ran a few pictures through Gigapixel AI, so let's try to compare the picture to regular side stampings. So first, it's very clear that this isn't a single stamping, or even a rack full of stampings. As in several places, it's easy to see the contour of the other side of the chassis. Next, let's focus on the region behind the rear door and D-pillar, which in the stamping is convex and bulges outwards to form the visible rear fender. In the invitation, however, this area seems to be concave and tucked inside, which fits my theory that it should carry a stamped fender. Finally, Gigascaling the slightly different picture, which Tesla included in its RSVP confirmation email, produced a very different result, which looks very much like castings. Make of it what you will, but I'm taking this one with a huge grain of salt. 9. A Tesla insider spills the truth. Granted, seeing the fender area in that grainy picture as concave could very well be wishful thinking, so I'll stop talking for a moment and let a Tesla insider do the explaining for me on why the chassis is fully cast. First, let's hear him explain the importance of gigacastings.
Right. And when you try to join all these dissimilar metal, dissimilar alloys, and you have galvanic corrosion, so you've got to have better seal, and you've got gaps that you've got to seal, and you've got to join these things, and some of them don't. Some of them need to be joined with rivets. Some of them need to be joined with spot welds. Some of them need to be joined with resin or resin and spot welds. And it looks, frankly, it looks like sort of a bit of a Frankenstein situation when you look at it all together. And it's I can't emphasize enough the nightmare of sealing in between the gaps. That is like that might be the most painful job in the whole factory is spackling on the sealant. Yeah. And then you have a little. If there's like a little error with curing the sealant, or like just somebody who's been working for several hours makes a slight mistake, then you've got now you've got an MBH issue because you've got a little hole and you've got a leak issue, and it's just like this is terrible. So, you can muscle through it, and we have, but it's just it's way better to have a single piece casting, and then you don't have any gaps, no sealant, you don't have dissimilar metals. And you can reduce the size of the body shop dramatically. Right. So just having the rear body castings for Model Y allowed us to reduce the body shop by 30%. Yeah. So there's roughly 1,000 robots on the Model 3 body line, which, by the way, is also not a figure of merit. You want fewer things, not more. Yeah. We got rid of 300 robots just with that rear body casting. Yeah. And then when we go to the front body casting, we'll get rid of another 300 robots.
Now, let's hear Tesla's plans for the Model 3 chassis.
Right. At some point we'll probably switch to a single piece casting, but I think we need to get probably the Texas factory and the Berlin factory going.
Yeah.
And like we need a, like we do have an issue of like it's hard to change the wheels on the bus when it's going 80 miles an hour down the highway. So you know, Model 3 is like most of our, or was most of our volume. Model Y will become, it will exceed Model 3. But it's just, we just need basically an opportunity to kind of redo the factory without blowing up the cash flow of the company.
Right.
10. One piece or more. I believe that one of Investor Day's major revelations should be a fully cast chassis that will greatly simplify production and enable Tesla to continue its exponential growth. But will they do that chassis as a single Teracasting, or just Gigacast the upper part and marry it to the bottom? As previously said, I believe they'll choose the latter. They may eventually cast Model Tau's chassis as a single piece, but I don't see this happening just yet, for the following reasons. First, there's risk reduction. It's much safer to cast smaller parts separately and then connect them than to do everything in one piece. This gradual approach is also how Tesla developed Model Y, first starting with megacastings, then growing to a single rear gigacasting, and only later adding a front one as well. Assuming Tesla reaches the pi before the smaller tau, another reason could be size. The larger the parts are, the more difficult they are to cast. So Tesla will probably want to gain experience and Teracasting a smaller chassis before doing it on the larger one. Another reason for favoring separate castings relates to Tavi's words on the thin-pillared upper body benefiting from using different materials than the lower chassis. Casting the upper body as a separate part enables Tesla to use different alloys for each section, giving each section slightly different characteristics. I do have an idea on how to Teracast the entire body as one piece while using different alloys for each section, but it won't necessarily work, and casting the chassis as separate parts would definitely be easier. And then there's the issue of marginal utility. As sexy as a Teracasting might seem, it's very unclear whether doing it is even worthwhile compared to joining separate Gigacastings. Gigacasting entire sections saves hundreds of robots and numerous parts and processes, so no wonder that Tesla wants it. But the only things saved by going to Teracasting are a few connectors and the process of connecting the Gigacastings together. Since this process is relatively straightforward and can be automated as very few steps, the benefits of Teracasting instead of connecting Gigacastings will be small. And to top it all, there's no TerraPress. A Tesla insider previously leaked that single casting the chassis would require Tesla to use 12,000-ton gigapresses. However, as far as we know, the largest gigapresses currently available are two 9,000-ton units, one of which recently arrived at Austin and the other shipped to an IDRA customer in Asia. Note that the 9,000 versus 12,000-ton difference by itself doesn't rule out Teracasting, because that insider could have been wrong, or maybe a later breakthrough enabled Tesla to start Teracasting using smaller machines. However, that's in theory. But realistically, this isn't the case. Elon specifically said that the unit arriving at Austin is for Cybertruck, and while work on the Highland production line in Fremont is currently underway, no new gigapresses arrived at the factory. So using separate gigacastings has the advantages of lowering risks and enabling use of different materials in each part, and the benefits of Teracastings are probably small. Add to that no Teracasting machines are currently available, and it's clear why I think the top will be separately cast. 11. Aluminum or aluminium? Americans say aluminum, and Brits say aluminium. So which is it? My answer is, who said it's any of them? I previously said that one of my ideas for making a cast upper structure has to do with treating alloys as composite materials. My idea specifically applies to casting aluminum alloys, but it's also possible to ditch aluminum and make the upper structure from plastics or composite materials. Let's listen to Sandy Munro.
When you go to those three, let's say three structural members, you put a body on top of that, it's going to be a perfect build. And as a guy who had to work in body shops, and as a guy who used to make molds and dies and whatnot, it's really difficult to take a whole bunch of pieces and glue them together, and there's nothing, right? I'm just using fixtures and then some
you're going to have
purchasing
tolerance stack up. And so like if Lego can be that precise, then so could a car.
Exactly. Actually, I got to tell you, I applaud BMW for putting out the i3, but it ugly. But the thing that we got from it was that carbon fiber body was absolutely perfect. Mm-hmm. And if you had the stiffness of the castings down below, and you take a carbon fiber basically structure and put it over the top, absolutely every door is always going to be perfect. You won't have to have fixtures, you won't have to have anything, it just goes boom, done. That's ultimately what I think a perfect build is probably going to go for. But most people don't want to do it because they're talking about, oh, carbon fiber is so expensive. No, it's not. It's not really that expensive. And at the end of the day, you have to take it and look at it, a total accounted cost.
Yeah.
How much does it cost to basically, where's all the tooling and whatnot? How about all the scrap that you get, on and on and on?
The traditional way of creating composite structures, as shown in the BMW i3, could be very worthwhile for creating an upper structure, which would then be married to the rigid skateboard below. This option seems promising, but I think it falls short with regards to Tesla's goals of building a fully automated alien dreadnought. For this purpose, however, an even better way exists of casting the upper chassis from plastics or composites. It's fairly easy to have a fully automated, simple process of casting or compression molding the carbon fibers and resin into the desired upper chassis shape. Composite materials hold several potential advantages over cast aluminum, as for example, the chassis will probably be lighter, and unlike cast aluminum, composites can also be used for grade A visible surfaces. Having said that, however, and without completely ruling out this option, I strongly believe that Tesla will cast the upper chassis from aluminum alloy, and I have two reasons for that. The first is speed. As far as I know, composites need curing, while Tesla wants its alien dreadnought to eventually spit out chassis in less than a second. But there's another reason that I believe that the upper body will be cast, and it's a reason so big that I'll give it another section, as this section's name is 12, Bullish. I'll now add the final dot I have, and it's one that put a huge smile on my face. We've been given a hint that Tesla will use cast aluminum upper structures, and it's been out in plain sight with nobody noticing the significance of this hint. In fact, it took me this video to realize it myself. As drone footage shows us, in recent weeks, Tesla started stockpiling in their factories thousands upon thousands of front and rear castings. Since stockpiling contrasts with Tesla's just-in-time philosophy, this raises the question, why? With all previous points in mind, the answer is simple. Tesla is stockpiling on front and rear castings because very soon the gigapresses will be busy making upper structures. As I previously said, Tesla didn't receive any new gigapresses lately, so they will use the current ones to also cast the upper body. For that reason, they're stockpiling thousands upon thousands of gigacastings so that immediately after the reveal, the press could focus on making upper structures alone. Having the other castings ready will significantly help the pace and enable a truly massive launch wave. To let that sink in, let me repeat it, breaking down my most bullish prediction. If this last dot is correct, Tesla will launch a new car. I don't know whether Pi or Tau. It will have a fully cast chassis and will be very cheap and fast to build. They plan to ramp production like crazy. And all this won't happen 2 years from now, and not even next year. It will happen almost immediately after Investors Day. More specifically, if the car's name really is Pi, deliveries will start 13 days after Investors Day, on Pi Day, March 14th, 2023. Let that sink in. 13. Even more bullish. I rushed an update to my narrator friend because news broke of Giga Shanghai pausing Model 3 production and upgrading the line. This supports my case for Tesla producing the Pi right after Investors Day, and the significance is huge. When Tesla lowered prices last month, analysts bemoaned giving up their margins. And this is where Elon's Project Highland 3rd Gen platform is a game changer. Tesla's previous margins of around 30% are misleading because they reflect a mix of, let's say, 40% Model 3s and 60% Model Ys. Model 3's ancient production methods result in low margins, which dilute the real bonanza of Model Y margins being 40 to 50%, or even more when FSD is considered. Applying January's price cuts raised huge demand but slashed margins. If Tesla replaces the 3 with Pi, margins will jump back to their previous level and maybe higher. With exponentially growing sales and huge margins, Tesla will take the world by storm. Analysts and OEMs alike do not see this coming. 14. You can help too. Let me know below what you think. Will Model Pi have a cast upper structure, or will it use stampings? Will they do a single Teracasting or marry top and bottom? When will the car arrive? And how will the stock react? Let me know below. I read all your comments. My next video will deep dive into wiring, seats, and Tesla's unique drive factory concept, so make sure to subscribe and hit the bell icon to get notified when it's out. Patrons are the ones who make this channel possible, so please consider supporting me on patreon.com/connectingnodots. You'll get ad-free early access to videos, as well as Patreon-only videos, including additional details on Project Highland. A super thank you for the super thanks to Mike Wayshak, Thomas Cummings, Sarish Gajwani, Neil Broderick, and Mark H. A huge shout out to my latest YouTube channel members, Fred B., Claus W., Wayne G., Rebel Aquaphonics, J.O., and Ed M. And to my latest patrons, Jesse C., Tom L., Mark E., Paul S., Tesla Howie, Larry H., Thomas S., Thomas K., Sphinx, George H., Ellie Pyatt, Aaron Y., Amir T., Andreas S., Baca, Ben F., Benedict K., Bleeze, Bradley B., Bradley DT, Brooke M., Carlos, Chad F., Christopher C., Christopher H., Craig H., Craig J., Kurt H., Daniel D., Daniel H., David R., Dennis C., Dion C., Don V., Fabio M., Frederick P., Guy K., Gerardo D., Gord W., Gordon M., Grant, Guillermo O., Happy W., James V., Jan, Gene F., Joe, Joenson C., John, John W., John K., Jumpin' Jim, Justin L., Keith C., Klaus H., Larry G., M., Mad Manx, Mark R., Marcus E., Min T., Montana H., W. Warger, Nathan W., Nicholas M., Oliver H., Pascal C., Patrick, Patron Pill, Privileged WMV69, Rajiv A., Rick the Wheelie, Roger F., Ronald VDV, Roy M., RW, Ryan L., Scott K., Sergi K., Simon B., Sleepy M., Steve G., Stephen B., Sterla S., Sven L., Tari J., Thaddeus M., Ren M., Yahalom U, and Yun Z. Thank you for all your support, and all my patrons, you guys rock. Twitter is becoming the place to be, so I invite you to follow me there. I'm Connecting No Dots. I tweet several times a day with everything from long threads analyzing Tesla matters to making memes and hanging out with you guys. So, see you there. Until next time, I am Connecting the Dots, and you are amazing.